Simplifying fractions. Simplifying fractions means writing them in the lowest terms possible. In other words, a fraction is fully simplified when it is not possible to divide its numerator and denominator by the same number, i.e. when numerator and denominator are relatively prime. For example, the fraction 12/25 is simplified to the lowest terms as, although we can divide individually 12 and 25 by other numbers besides 1 and themselves, i.e. none of them is a prime number, we are not able to divide both of them simultaneously by the same number. This means these two numbers are relatively prime, as explained in Math Tutorial 1.6. Example 1. Which of the following fractions can be simplified and which not? We have the following shown on screen. Solution 1. We must check whether numerator and denominator of the above fractions have any common factor or not. We have the following shown on screen. Thus, the fraction 15/27 can be simplified by 3 to obtain 5/9. As for 18/54, we have the following shown on screen. Thus, we can simplify 18 and 54 by 2 times 3 times 3 is equal to 18, to obtain 1/3. For 14/15, we cannot identify any common factor because we have the following shown on screen. For 21/35, we have the following shown on screen. Thus, when dividing both the numerator and denominator of 21/35 by 7, we obtain the simplest form of this fraction, i.e., 3/5. As for 78/93, we have the following shown on screen. Thus, simplifying by 3 both numerator and denominator of 78/93, we obtain the simplest form of this fraction, i.e., 26/31. Finally, for 55/88, we obtain the following as shown on screen. We can find any missing component of a given fraction when another equivalent fraction is known. Example 2. What is the value of m that produces equivalent fraction in the cases shown in the following on screen? Solution 2. A. We simplify the known fraction to the simplest terms. We have the following shown on screen. Thus, we have the following shown on screen. Hence, since the second denominator is 5 times greater than the first one, so must be the numerator of the second fraction in respect to the first denominator too. We have the following shown on screen. Thus, a equals 25 because 25 divided by 5 is equal to 5. B. We use the same approach as in the previous example. Thus, first we simplify the known fraction to the lowest terms, we have the following shown on screen. Hence, we have the following on screen. Therefore, since 5 times 3 is equal to 15, then 11 times 3 equals a. This means a equals 33. We can apply twice or more the multiplication and division of numerator and denominator by the same number to check whether a fraction is equivalent to another or not instead of expressing both fractions to the lowest terms. Thus, if we have the fractions 27/45 and 18/30, we can write the following as shown on screen. In this way, we proved that the two original fractions are equivalent. That is all for lesson 3.1.4, and the end of tutorial 3.1. To continue this chapter, please watch 3.2, Proper and Improper Fractions. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.